Okay, so today we're going to look at lesson 4-3, the 3-point method and linear regression. Now, you're going to be thrilled to find out that I'm going to let you use your calculator on these. So I'm going to show you how to do these on the calculator. You're going to have to do some things by hand, but the rest is on the calculator. If I could import my TI calculator on here, I would, but I have yet to figure out how to do that. So for the time being, here we go. Okay, so how could you write the equation for a parabola if you only knew 3 points on the curve and none of these were the vertex? So what if you had these 3 points here and you wanted to find out what the curve was? Like maybe it went like this. I mean, I don't know. My guess is it's going to go something like this. We'd have to know the vertex in 1 point, but we only have 3 points, and these are our 3 ordered pairs off of this graph. So here's the procedures right here for you to follow. You're going to create a system of equations by substituting in the given points. Well, what do you substitute them into? Well, you're going to use y equals ax squared plus bx plus c. So you're going to create a system, and now we have 3 unknowns. Our unknowns are a, b, and c, because we've got 3 xy's and no a, b's, and c's. So we're going to use this x and plug it in here, and this y and plug it in here, and create an equation that has a, b, and c in it. Then we're going to do the same thing again, but with this x and this y, and with this x and this y. So then you're going to have to solve the system, but I'm going to show you how to solve that system on the calculator. So here we go. All right, so the very first thing we're going to do, and actually I'm going to show you how to do it on the second example, but I'll show you how to set up the first example, and I'll give you the answers so that you can try it later after I show you the second example. So first thing we're going to do is we are going to start with a, and we're going to plug in for x squared and plug in for x, and I always put y, whoops, I don't want to put y there, I always put y on the right, and you should too. So then I'm going to sub in this for x, the -1, and this for my y, the +3. And then you're just going to multiply it out. So the equation that I get is -1 squared is 1, so I get a. -1 times b is minus b, and then plus c equals 3. So there's one of my equations. Actually, I think I'm going to write that over here to the right. So a minus b plus c equals 3. It'll be easier for me to collect it all together. All right, then our second equation, we do the same thing, but we're going to use the second ordered pair. So this time, I'm going to use this x and this y. So 2 goes in for my x, and -3 goes in for my y. So 2 squared is 4, times a is 4a, 2 times b is 2b, and then plus c equals -3. Then my last ordered pair, I'm going to use this for my x and this for my y. So I'm going to put in 3 for x and 3 for y. So this time, 3 squared is 9 times a, b times 3 is 3b, and then plus c equals 3. So now we've got this wonderful system of equations here. So I taught you how to solve a system of 3 equations with 3 unknowns way back when in our systems of equations. There is a way to do this on the calculator, which I'm going to show you an example too, because it's easier for me to show you where the steps are there. Just know that the solution to this one is A is going to end up equaling 2, B is going to end up equaling -4, and C is going to end up equaling -3, giving you the equation y equals 2x squared minus 4x minus 3. So go ahead and follow the procedures outlined for you in example 2, and then go ahead and try this one on your own and see if you can get the answer that I just gave you. So let's go on to example 2. I'm going to explain the procedure to you, and we'll go from there. Okay, so here's example 2. Make it a little larger. So we're going to do the same thing we did in example 1. We're going to set up our system of equations. So I'm going to do the substitution in my head and show you the result of what I did. I'm not going to write everything else out. Well, I guess I could, but I'd really rather not, to be honest. So I'm going to plug this in for x, and this is going to be my y. And so if you recall, I am using ax squared. Oh, it's right here. I'm writing something that's already here. So I'm going to use this right here to plug into. But I like to put my y on the right. So 1 squared is 1 times a is a. 1 times b is b, plus your c is equal to -2, because that's my y on the first ordered pair. So I just used this ordered pair here. I plugged in 1 for each of the x's, and I plugged in the -2 for my y. This time I'm plugging in the 2 for each of my x's, and then -4 will go in here for my y. So 2 squared is 4 times a. 2 times b is 2b, plus c is equal to our y, which is -4. And then now I'm going to use this xy. And so 3 squared is 9 times a. 3 times b is 3b, plus c is equal to -4. So then this is our system. And then I want you to write down the following procedure. And so here we go. So our procedure on your calculator. So write down the procedure first, and then you can try to follow it on your calculator. So the first thing that we're going to do, step 1, is you're going to hit the second button and then the x to the -1 button, and you'll notice that above the x to the -1 is the word matrix. We're getting into the matrix menu. And then you want to scroll over to edit and hit enter. So that will bring you to a screen where you see matrix A, and then it probably has 1 by 1, or it could be like, for instance, on your TI, you might want to write this over here down below. So on your TI 84 plus, you're going to want your rows go by your columns. So that's what that 1 by 1 is, 1x1, 3x4 that you see in this edit menu. And then you have a whole bunch of zeros that are down below. So the rows by columns just means these are your rows. So you got 3 rows, and these are your columns. So you have 4 columns. So we're going to put in there, underneath that edit menu, 3 by 4. So that's your size. So while you're in that edit menu, you need to put in 3, enter, 4, enter, where it says, it probably says a 1 by 1 here. So it should look like something like this right next to where it says matrix A. So when you hit enter, it should bring you down to the very first. You're going to see something like this. You're going to see all these zeros. 1, 2, 3. You're going to see all these zeros, where you're going to fill in each of these zeros with the values here. So you're just filling in the coefficients. You're ignoring the A's, B's, and C's. So the coefficient here is 1, so you're going to put a 1 here. Coefficient here is 1, so you're going to put a 1 here. 1, you're going to put a 1 here. So the matrix that you input, and you have to be careful, because as you put 1 enter, it's going to move you this direction. So you have to be careful, and this is what the matrix should look like when you're done. So we're still under procedure 1, but your matrix is going to look like 1, 1, 1, negative 2. That's your first row. The second row is 4, 2, 1, negative 4. Your third row is 9, that's a 9, 3, 1, negative 4. So that's what you want underneath this edit right here. All right, so once you do that, then you're ready for the next procedure. So then your next procedure is going to be, so second one, then you're going to do second, and then you're going to hit the mode button. The mode button is right next to the second button, and the reason for that is it quits this. It gets you out of the matrix menu and into the main calculation menu, you know, where you do 2 times 3 is 6, if you want to do something like that, to get you out of there, because we're getting ready to take this matrix right here that we put in there, and we're getting ready to actually have it calculate the answer for us. So once you're back in the main screen, the home menu, if you will, then this is your next step. So step 3, you are going to do second, and then x to the negative 1, so we're going back into the matrix menu, and then you're going to hit math. So you're going to scroll over to math. And then from there, you are going to scroll down until you find the following. So you are going to scroll down and look for, you're going to scroll down this direction, and you're going to look for something that says RREF. So on my calculator, there's one that's just a single REF. You want the RREF. So for my calculator, that's B as in boy. That gets you there. So then you want to hit enter. And you're back on the home screen, and on the home screen it actually shows RREF with parentheses. So then we need to go in and name, we need to actually go in, I'm going to erase this so it doesn't interfere with what I'm doing. Then we need to go in and actually name what matrix we want it to find our answer to. So our last step is to go back into the matrix menu, second, x to the negative 1, and then you're just going to choose 1 and enter, because the first one that you come to is the name. So when you do second, x to the negative 1, you're under the names menu, because that's what's highlighted, and the very first name is matrix A, and you're just going to hit enter. And from that, then from there, you're looking at your home screen. It says RREF parentheses, and it's got the matrix A name there. You have to hit enter one more time, and it's going to give you the following answer. Okay, so that's where we're going to find our answer. So notice that you have all of these zeros, but then you have this diagonal ones. This is called your identity, part of the matrix. This right here is the solution that we're looking for. So we are searching for this right here. This is going to become our A, this is our B, and this is our C. So now we can actually go ahead and write. y equals, our a value is 2, so 2x squared. Our b value is -4, so minus 4x, and our c is -3, so minus 3. And you can always check this by putting this part right here into the y equals of your calculator, then graphing it, and then you can go to the table value, which is second graph, go into the table and input the x values for these ordered pairs and see does it give you these y values. So you can always check your answer that way. All right, so now you try it for this one. So you're going to use these 3 points right here in your calculator, and you're going to create a matrix, and you're going to find the answer. So you pause the video, find your matrix, and then go from there. Okay, so I'm just going to go ahead and go through here, and I'm going to write out what the matrix should have been that you got. So when you plugged in these 3 x and y values into ax squared plus bx plus c equals y, you should have gotten the following systems of equations. So you should have, for the first order pair of 1, 3, you should have a plus b plus c is equal to 3. For the second ordered pair of 2, 5, you should have had 4a plus 2b plus c is equal to 5. And then for the third ordered pair 3, 6, you get 9a plus 3b plus c is equal to 6. So the matrix that you put into your calculator should have looked like this. And then the matrix that you get out of your calculator should look like this. Now on this one, you actually got decimals here in this column, but remember, when you're looking at this in your home screen and you've got decimals here, you just have to hit math enter enter, and it will convert those decimals to their fraction form. And so you should have -1/2 and then 7/2 and 0. So based upon this, your equation is y equals -1/2 x squared plus 7/2 x, and I'm not going to write plus 0 for my c. Now, the next question says, and the other part of the question here, the top of the goal cage is at 5, 6. So we're going to go ahead and put the top of the goal cage at 5, 6. I'm going to move this over, and so here's 5, and then here's 6. So I'm going to plot a point at 5, 6 right here. So that's the top of the cage. So the top of the cage must be, something like this, 5, 6. And the question says, let me move the question back over a little bit. Will the ball go over the goal? If not, will it hit the goal? So 5, 6. So if I put 5 in for x into here, so you can put this into your y equals, and if I put 5 in for x, my y value will turn out to be 5. So 5, 5 is right here. So essentially it's going like this, right? So the question is, will the ball go over the goal? If not, will it hit the goal? Well, the ball is going to actually go into the goal and score. So no, the ball will not go over the goal. It will hit the goal and score, or go inside the goal and score. All right, now we're going to use what's called quadratic regression. So what I want you to do is use these exact steps as you see them. We're going to put these values into L1 and L2. So this is going to be your L1 and this is going to be your L2. So it is talking about time. So for 24-hour clock, we're going to use a 24-hour clock after noon. So after 12 p.m., you just keep adding this number to 12. So 12 plus 2 is 14. So for this number, we're going to put in 14. Then 4 plus 12 is 16. So for this number, we're going to use 16. And then 6 plus 12 is 18. So this number, we're going to use 18. So what are you going to put in your calculator? So you're going to start off by pressing stat. And so stat is right there to the left of your toggle button. So you're going to press stat and you're going to enter your list. So from stat, you just hit enter and you should see L1 and L2. There might be numbers in your L1 and L2. If that's the case, highlight, just go up and highlight the L1 and just hit the clear button and then scroll down 1. It'll clear the whole thing. Don't hit delete, hit clear. Then if there's anything in L2, you don't want anything in any of your other lists. So you just want only things in L1 and L2. So put in 8, hit enter, 10, enter, 12, enter, 14, enter, 16, enter, 18, enter. And then you just have to scroll to the right once and it'll pop you right back up at the top. Then enter these values. Make sure that you have the same number of data items in L1 as you have in L2, otherwise it won't work. Then you're going to turn on your stats plots. To turn on your stats plots, there's 2 ways to do this. Way 1 is if you go into your y equals, you see at the very top of your y equals plot 1, plot 2, and plot 3. If you scroll up and highlight plot 1, it'll be flashing. All you have to do is hit enter and it'll turn it on. That's the easiest way to do it. So that's what I suggest you do. So that's how you turn your plot on. Then for step 3, they're suggesting you use zoom 9. I suggest you go to your window. So hit your window button. You're going to see X min, X max, Y min, and Y max. Don't touch the scale. This is going to be your X. This is going to be your Y. So your smallest X value is 8. Your largest X value is 18. So in order to view your window, I would probably go from 0, because it's close enough to 8, to 20. So make your X min 0 and your X max 20. Then your smallest Y value here appears to be 52. And your largest Y value is 81. So I would probably go from, you could go from 50 to 100. So your Y min would be 50, your Y max would be 100. And so put that into the window. Then you're going to do second quit to get back out to the main screen. Then we're going to do regression. We're going to find a regression equation. So we're going to hit stat again. Then you're going to scroll over to calc. And then in that calc menu, you're going to scroll down to number 5, which number 5 says the following. I'm going to write it here. Number 5 says quad regression. Okay, so that's what number 5 says is quad regression. And so you are going to scroll down and then you're going to see where it lists the following. It's going to say X list L1, Y list L2, freak list, store regression equation, and calculate. You want to scroll down, and you want to hit, well, not scroll down, you just want to hit enter. Enter, enter, enter until that calculate is flashing. And now it's ready to calculate. Just hit enter one more time and it is going to calculate for you the actual equation. And it is important that when you get the actual equation that you round as far as possible. So I suggest we're going to round to the nearest, well, let's round to 3 decimal places. That should be good enough for government work. So in this particular case, they give you an A, a B, and a C. And so that's your, ax squared plus bx plus c. So your a in this case should have been negative 0.468. It should round to that, and that's going to be our x squared. And then our b is plus 14.716. That's our x. And then minus 36.121. So that is the equation that approximates those points. Now, if you go to your graph and you look at your graph, if you hit graph, you should see, and your stats plots is on, you should see the kind of a funky looking graph. And then if I were you, I would put this part right here into my y equals, and it should approximate what it looks like on that graph. In fact, this should create a line that goes through those points on your graph. If it doesn't, then you did something wrong, or you didn't go out to enough decimal places. Then the other thing you could do, that's just a great check, is to see, does this line actually go through those points? So you have to make sure that your window is correct. So again, you have to make sure that your window is correct and that your stats plots is on, otherwise it won't graph. Now, what I would like you to do is try example 4. So to clear out your L1 and L2, you're going to highlight L1. So go all the way up to L1, highlight it and hit clear, and then scroll down, and it'll clear out everything we just put in there. Do the same thing on L2. So this is going to go in L1, this is going to go in L2. Remember to change these to use the 24-hour clock. So pause the video, and then I'll give you the answers here below. Okay, so hopefully you used 15 here, 18 here, and 21 here. All right, so then when you plug this into your regression analysis, you should get y equals negative 0.329 x squared plus 9.798 x, and then plus, I'm running out of room, 15.571 for your equation. Now, it does say, when does the high temperature occur? That's going to be your X value for your vertex. So if you go into your second calc menu and find max, and go to the left of your vertex and to the right, you should come up with a max temperature of 14.87, that's the time, and the max temperature is 88.43. So 14 on the 24-hour clock is, and 14.8 is really close to 3 p.m. for the day. It's a little less than 3 p.m. All right, let's do the final one. So you're going to put this final one in, so pause the video and put this in, and I will give you the answers. So here are your answers. If you do your linear regression, you should get y equals 3 point, I just lied to you. How about this? Y equals, the linear model. So if you hit the linear regression instead of the quad regression, and you'll see that on there, the linear regression would look like this. So that would be your linear right there. So that's A. Your B is going to be your quad regression. So that would be y equals x squared, and then minus and then plus. All right, and then finally compare the models on which is better. It appears that the quadratic model does a much better job at modeling because the curve actually touches more data points accurately than the linear model is. So if you put both of these equations into y equals, you'll see that this equation approximates the data a whole lot better. All right, so have fun with your homework.